Welcome back. So, if you're an intermediate Solana developer who has ever sweat bullets through a 20-step manual deployment checklist on a Friday afternoon, well, you are exactly in the right place. Today, we're taking those nerve-wracking manual steps and transforming them into smooth, reliable, and completely scripted workflows.
We've all been there, right? You're staring intensely at a terminal window, meticulously checking off steps on a physical notepad, absolutely terrified that one single typo is going to cost you real money and wasted SOL. Or worse, leave your on-chain program completely broken. It's kind of this shared pain we all have in the Web3 space. But honestly, it doesn't have to be this way. In this explainer, we're introducing automation as the ultimate stress relief solution for your deployments.
Think of today's explainer as drafting an engineering schematic together. Here's our blueprint. First, the idempotence engine. Second, automation trade-offs. Third, mapping the schematic. Fourth, the automated pipeline. And finally, a component breakdown. Let's get right into it.
Part 1. The idempotence engine. Let's dive into the core physics that actually makes our automation run safely.
I really want to hammer this definition home because it's the absolute foundation of everything we're building. Idempotence. It means that running the exact same script twice produces the exact same on-chain state, completely without error. This repeatability, achieving your goal without triggering weird side effects or double spending on duplicate transactions, that's the linchpin. It's what turns a brittle script into a rock-solid workflow. Think about it. If your script crashes just because a program ID already exists on-chain, well, it's not idempotent. We want scripts you can run 100 times safely, knowing the outcome will always match your desired end state.
Part 2. Automation trade-offs. Now, before we go and automate the entire universe, we have to weigh the costs. When writing deployment scripts, we're looking at a classic rule of 3. First up, speed versus control. Automation is incredibly fast, for sure, but you are handing the steering wheel over to a machine. Second, complexity versus repeatability. Writing robust TypeScript adds some upfront complexity, but man, it guarantees flawless execution down the line. And third, maintenance burden versus risk reduction. Maintaining scripts definitely takes time, but it practically ensures human error won't ruin your deployments. It's a trade-off, but a really good one. Part 3. Mapping the schematic. Okay, it's time to deconstruct your manual machine into automated gears. So here's the trick. You have to treat your current manual checklist as your absolute source of truth. Every single manual task gets mapped to a strict script responsibility, followed immediately by a verification step. Setting environment variables by hand? Stop that. The script now loads and validates your .env file, failing fast if anything is missing. Building? That maps to generating a checksum. Deploying? That maps to a CLI dry run. Literally every manual gear gets a verifiable, automated replacement.
Part 4. The automated pipeline. Let's actually look at the flow of our newly automated engine.
Here is the canonical workflow pattern you're going to want to adopt. Step 1, prepare the environment. Step 2, validate artifacts. Step 3, upload and deploy. And Step 4, verify the on-chain state. If you walk through this sequence, you can really see how it enforces our anchor concept of idempotence. Like if Step 2 fails because an artifact is missing, Step 3 never dangerously fires. Or if you run the pipeline twice, Step 2 realizes the artifact hasn't changed at all, gracefully skips the deployment in Step 3, and jumps straight to verification. It's basically a one-way street of logical safety checks.
The core architectural principle keeping this whole pipeline stable is separation of concerns. We are physically separating 3 distinct phases in the code: environment setup, the deployment action itself, and verification. By deliberately keeping these separate, you drastically reduce accidental coupling. Plus, it makes retrying failed scripts incredibly safe. Because if the verification phase fails, the last thing you want is to accidentally re-trigger a massive, costly deployment when you run the script again.
Part 5. Component breakdown. Let's transition over to the actual TypeScript structure that makes this happen.
So those manual tasks we talked about, they've now transformed into really specific, actionable TypeScript functions. Things like validate environment or deploy program. The key takeaway here is that each function absolutely must return a clear status code or throw a well-defined error. That way, your main orchestration script knows exactly what to do, whether it needs to retry, roll back, or just safely abort the whole operation.
This brings us to a really crucial point. You have to design your scripts to fail fast, and you must use checkpoints. You absolutely need to separate non-destructive checks from actions that actually alter the on-chain state.
Before your script does anything destructive, like, say, overwriting an existing program buffer or spending your SOL on rent, it needs to record the pre-action state. Your script should be asking, what's the current program ID? What are our exact wallet balances right now? What's the current on-chain code hash? By always doing dry runs and creating these state checkpoints, you guarantee that you have the exact data you need to do a safe rollback if things go completely sideways during a live deployment.
Let's look at one specific, really powerful example of this in action, the checksum anchor. By using Node's native crypto and FS modules, you can easily hash your compiled Solana artifacts using something like SHA-256. Why does this matter so much? Well, a simple checksum function is basically the perfect real-world example of idempotence. Your script looks at the current build artifact, hashes it, and compares it to the previous hash it saved. If those hashes match, the script essentially says, hey, nothing changed in the code, and it completely skips the heavy build and deploy process. It saves you time, it saves you money, and it stops redundant on-chain transactions from cluttering up the network. It's a total game changer.
So, we've mapped the schematic, we built the engine, and we've broken down the TypeScript components. Now, I want to leave you with this final thought. What manual step will you automate away today? I really challenge you to look closely at your current Solana deployment process. Just write a compact summary of 1 or 2 things you can script right now and start ditching those nerve-wracking manual checklists for good. The transition definitely takes a bit of work up front, but the peace of mind and reliability, it's entirely worth it. Thanks so much for joining me on this explainer, and I will catch you next time.